There we go. We're recording Tuesday the 22nd of September in our geometry, high school geometry class at WSSB. And our objectives today, we're going to finish 1.6, a plan for problem solving, and discuss what we worked with yesterday. We're going to do some practice problems in this section. And then we're going to move on into our review. In the Chapter 1 review. We're in Volume 3, and we ended up on page 37. I think it was probably 37A.
Question mark?
Yeah, 37 question mark. So if we can get ourselves to 37. You print, it's 37 in the middle of the page.
37.
What the heck, Justin?
So what do you remember about what we discussed yesterday?
We talked about perimeter and area.
Perimeter and area. Okay. Base times height for the area. The area of what? Rectangle and
Parallelogram.
parallelogram. We can use the same formula, base times height, for both shapes, can't we? Because rectangle, the traditional formula for a rectangle for area is what?
Length times width
Length times width, right?
Or length times width.
Length times width. We're talking about
Why
area,
did I say
not
length times
volume.
width times height?
That's volume. That's
Oh,
volume.
you're right.
We're going to
You're
get
right.
there, yeah. We're just talking about the surface, right? So length times width for rectangle. Then we transferred that information to a parallelogram. Parallelogram. We manipulated our parallelogram and found out, oh, if we move one side of it to the other side, it becomes a rectangle, and then it's still length times width, but we can't say that in a parallelogram because parallelogram doesn't have a quote-unquote width, right? It's tipped over, so we have to have a height, right?
I think of it like a hill.
Right. So if you, yeah, it's like a hill. So if you look at page, let's see, 37, let's try 37.
37.
Let's back up a page and go to just straight up 37. So back up to the thermofilm page 37.
Finally, I've been on it for a while.
Yeah?
Wait, no.
Oh, geez. We got to get you faster at this.
No, I thought I
36?
thought I found it.
Okay, there you go. All right, 37. And you look at the second tactile down, the one at the bottom. Okay?
Down there. It's got the little square in it.
You have a parallelogram, right?
Mm-hmm.
And it has several different measurements, doesn't it?
Yeah.
Indeed.
Indeed. Okay. What is the base measurement?
Well, 5.2.
5.2. All right. And what is the side measurement?
6 or 4.
4. Or 4 point. The side measurement off to the left?
4.8.
4.3.
4.3, yeah.
Oh,
And what is the height?
Oh, I thought that was an 8. Stupid dog.
Trying to find it.
The height?
4.
The
height. 4. Yeah, that's right. Good. 4. So a parallelogram has 3 different measurements that they could give you.
Mm-hmm.
They could give you the base or its length.
Mm-hmm.
They could give you its side, or I guess, quote unquote, its width, which is 4.3, but it's not really its width. It's just a side measurement. They need to give you its height or its altitude.
Yeah.
Altitude. That means how tall is it? Remember yesterday? I stand up straight and tall, and I am 5'4".
Yeah.
If I lean over a little bit, oops, I'm not that tall anymore, right?
You're
so
like 5'3" or something.
When a parallelogram's leaning over like that, it has a side measurement, but that's not its height. We want to know its altitude. So we have to have an indicator of that, and typically they show us that by drawing a dotted line, a dashed line, from the top vertex down to the base, and there's usually a little square down at the base of it. What does that little square next to our dashed line mean?
It's the base.
What's that little square you feel next to that dashed line? What does that mean?
I'm not sure.
A 90-degree angle.
Yeah, listen to
Oh,
Peggy.
right.
Yeah, it's a 90-degree angle. It means that it's perpendicular. If I stand up straight and tall, I am perpendicular to the floor.
Mm-hmm.
I'm at a 90-degree angle, so I'm at my tallest.
Yeah.
If you sit in your chair, nice and tall with good posture, you've created a 90-degree angle at your waist with your legs, right? You're perpendicular to your chair. Okay?
Mm-hmm.
So this line, this altitude is saying I'm perpendicular to the base. I'm at a 90-degree angle. I'm at my tallest.
Yeah.
I'm at my straight up and downness. Okay? All right. So for this particular problem, it asked us to find the area. So you just told me that area equals base times height.
Mm-hmm.
So what would we do to find the area of this particular parallelogram?
5.2 times 4.
5.2 times 4, Justin, yes.
20.8.
And it'd be 20.8, yeah. So we'd say, how would we label it?
Meters.
Meters
5 point.
squared.
Oh,
Good.
yeah.
Meters squared, because it's meters times meters, right?
Yeah.
X times X is
X
squared.
squared.
Meters times meters is
Meters squared.
meters squared. Good. All right. So did they give us some information that we didn't need to solve the problem?
Well, they got us a side measurement.
That side measurement. Now, if they would have said, find the perimeter
Right.
of this parallelogram, then what would we have done?
Look at the side measurement.
Look at the side measurement, and then what?
We would have added up the numbers.
Added up the numbers.
That's what you do for.
So what is the perimeter of this parallelogram?
7.5.
No. Almost.
Oh, wait,
or no,
wait.
5.2 and
15.
4.3 is 9.5. And then you double it, right? I think you made a miscalculation. You said 7.5 and it's 9.5? 5.2 and 4.3?
Oh, yeah. I did
9.5, and then double it, and you get 19. Good.
Yeah.
Little mathematical error. I knew what you were doing. All right. So then we needed that side measurement and not the height.
Yeah.
Sometimes you get combo problems. They might say, tell me the perimeter and the area, right? So then you need all the information. You're going to do a couple of different calculations. All right.
Mm-hmm.
So please move to the next page and find where it says some mathematics problems can be solved. Find it?
Let me see.
A37.
A37?
Toward the bottom.
Towards the bottom.
Okay.
All right. Tabitha? A37
Some
towards the bottom.
mathematical.
All right. You want to read it, Tabitha?
Yeah.
Okay.
Some mathematics problems can be solved by using a formula. Others can be solved by using a problem-solving strategy like finding a pattern or making a model. No matter what type of problem you need to solve, you can always use a 4-step plan.
All right. Before we move on, let's tap into things that you've already learned and practiced in this class.
Mm-hmm.
Do you recall solving a problem a while back, looking for a pattern?
Yeah.
Yes.
The sequence thing.
Those sequence things, that's right. You looked for a pattern, you figured out what it was, you named your 3 things. You actually went through a plan in your head without really giving yourself credit for it. You said, I'm going to find this pattern. Oh, I see, we're adding by 2. Oh, I'm going to add 2 and get the next. Oh, I see.
We're adding by 4.
They're adding by 4, or they're multiplying by 3, or they're going up by
5.
They're going up by 5 and then 6 and then 7
Or by
and then
10
8.
or
Yeah,
whatever.
and you figured it out, right? And you came up with what they were doing, and then you came up with a plan to figure it out. You didn't really say, oh, my plan is, right? But what you're typically doing is some sort of plan, whether you write it down or you automatically do it. And there's a suggestion that we can use a 4-step plan to solving problems in mathematics.
Yeah.
And you've done this. You do it. But we just give ourselves credit for it. So somebody want to read the problem-solving plan, the 4 steps. Number 1.
Those start like.
Explore the problem.
Explore the problem, Maria.
Oh,
So
there's
before we
there's
move on to
something in
number
there.
2, What does it mean by explore the problem? We got a mathematic problem in front of us. How are we going to explore it? What are we going to do, Justin?
Look at it.
Look at it closely. What things would we look at?
Look at the information that it says.
The information it says. What else could we look at?
How it's written.
How it's written. What else could we look at?
The operations that are going to be involved?
The operations involved. How else could we look at it?
Its format.
Its format. How else could we look at it? Is there going to be a picture, maybe?
With your fingers.
If there's a picture, we want to look at the picture, right?
With your fingers.
What else, Zach?
With your fingers.
Look with your fingers. Look with your usable vision. Explore the problem. Oftentimes, is there reading involved?
Oh, yeah.
Yes. This is where I give you some JJ hints to the problem-solving plan that I've probably told you before, and I'm going to tell you to them again. When we read a story problem for the first time, or a real-world problem, or an application problem, or a word problem, whatever name we want to call these silly problems that are in our books with lots of words and pictures, we read it more than once.
Yeah. Oh, yeah.
Because the first time you're reading it, you're just trying to get used to what it says. And if you're a Braille user, sometimes it's getting used to the Braille, right?
Yeah.
There's some weird words that you encounter, and you're like, what is that?
The
It could be
weird symbols.
So what you're doing is you're reading it more as just a reader. You're trying to be a good reader, but you're not really being a mathematician with it yet.
Yeah.
So you read through it at least once, maybe twice, just trying to get used to, do I understand all these words and how they're going together? Then you read it with purpose.
Yeah.
Well, what do I mean by read it with purpose?
There's a reason why you're reading it.
Know what you explore it, right?
Reread
Know
it.
what you're looking for. Look at, like Peggy said, look for key information or key words. Look at the drawing. Think about, hey, can I relate with this problem? Have I ever done it? Have I ever heard of it being done? Do I know somebody that's done it? Could I relate to the problem somehow so it makes it more real? Or is it completely foreign to me? And maybe I need to think about that or ask questions about that. You're reading it with purpose. You're talking back to it. I'm giving you permission to talk back. You're talking to the text. You're talking back to it. You're saying, that's interesting. Okay. Well, yep, I'm used to that, or I've been there, I've done that. Okay. That's all a part of this first little step of exploring the problem. Holy mackerel, that's a lot, isn't it?
Yeah.
But if we didn't explore the problem well, how successful do you think we're going to be in the rest of it?
Not very.
We're gonna suck.
We're going to lose information. We're going to get frustrated. We're going to get lost.
We're gonna tear up the book.
Yeah, because we haven't given ourselves permission to explore the problem, to think about it. You have been programmed in mathematics during your elementary schools most especially to be fast.
Yeah.
Haven't you?
Yeah.
Yeah.
Lots of timed tests.
Yeah.
Mad minutes, be fast. Come on, let's go. What's 5 times 9? 45. What's that? Let's go. Solve the problem. Faster. Do more. Let's go. And you think, understandably, and are programmed with, we gotta be fast.
Yeah.
And I'm telling you, stop it.
Hey, JJ.
Slow down.
Yeah.
You are mathematicians now. You are scientists of mathematics. Do we want our scientists to be fast?
No.
Not
Please,
really.
God, no. Scientists and engineers are fast. The space shuttle's
There's a
going to
problem.
crash.
There'll be a problem.
The airplanes are going to crash.
Yeah.
Hey, JJ.
Medicines are not going to work,
Yeah.
right?
Hey,
Our
JJ.
buildings are going to fall down on us. Our bridges are going to, we aren't fast anymore. We are mathematicians. We're problem solvers. We're slower. We're thinkers. We're going to explore the problem. It's not about get it done. You do not get extra credit for getting it done fast in advanced mathematics and in science and in engineering. You get the extra credit for a product that's well done and right.
Yeah.
Okay? So explore the problem. You give yourself permission to explore the problem. You don't get anxious that it feels like it's going too slow. Now, granted, if you're still looking at that parallelogram 2 hours from now, we might want to talk about some strategies to be more efficient, right?
Right.
Okay. Right? Thank you. But especially if you're encountering new information. Okay, what's the next? So we've explored the problem in all the ways that we've explored it. We've given ourselves permission to think about it and take our time. What's number 2?
Plan the
solution.
Plan the solution. So now that we've explored it and thought about it and found the key words and the operations we want to do and the facts we want to use and the things we know about the problem, we have to have some sort of plan for how we're going to get an answer.
Yeah.
Should I add? Should I subtract? Should I use the formula area equals BH? Should I, right? Yeah. You want a plan. Okay?
Should I?
Then what do we do after we come up with our plan?
We
have to make sure.
Solve the problem.
Have to solve it and make sure it's accurate.
Yeah.
Make sure it's accurate, yeah.
Right. Those are the next 2 steps, Smith. You're right. We're going to solve it and make sure it's accurate. We're going to solve it and we're going to examine it. So we do our plan. Don't stop there, right? Yeah. Sometimes math students, they solve it and then they move on. And they even stop to give themselves credit for what they just did. And does the solution make sense?
Yeah.
Does it answer the question that was being asked?
Right.
Don't stop believing.
Does it make mathematical sense? If we had a height of 4 and a base of 5, and we get an answer of 258 meters,
here's the problem.
We need to stop and go, wait a minute. I think I bumbled when I punched those numbers on my calculator, right?
Yeah.
How did I get a number so big?
Yeah.
Does that make sense?
It was magic.
Let me check my work.
Yeah.
Let me go back and do it again.
Always check your work.
Or let me plug it back in and see, right? So we're examining. So there's the basics. Explore, plan, solve, examine.
Yeah.
Explore, plan, solve, examine. Or you can put it in your own words.
So, examine.
Right? I see that
you could make a song out of
Erica
that.
took notes. Hers say explore, plan, solve, check.
Examine. Explore, put the plan, solve, examine.
All right?
I made an acronym.
Make an acronym?
EPSE.
EPSE.
Oh, C. There you go.
SE.
EPST. Or EPSI.
EPSE.
Explore, plan, solve, examine. EPSI.
Yeah.
Pepsi.
EPSI.
Pepsi.
Like
Zach.
PEMDAS. EPSI.
PEMDAS. Yeah.
Or all right, so let's try this strategy on our problem on example number 4. We're going to be mathematicians. We're going to be scientists of math. We're going to be these aspiring geometry attorneys, and we're going to apply this problem-solving plan and this permission to take our time and to be good mathematicians with it. So check out, Julia wants to paint. Find that?
Wait, I'm not seeing that yet.
Example 4, Julia wants to paint.
Yeah.
There it is.
Maybe she can't paint.
Which page is it on? Is it on 38?
B38.
Oh, I'm on A38. Okay, that's see it.
B37.
Or B37? I'm sorry.
Oh, never mind then. Yeah.
Your head too much. There you go, B37. It says Julia, down towards the middle of the page.
I should be able to find it then.
Julia wants to paint 2 rectangular walls of her bedroom. The bedroom wall is 15 feet long and 8 feet high. The other wall is 12 feet long, 8 feet high. She wants to put 2 coats of paint on the walls. She knows that 1 gallon of paint will cover about 350 square feet of surface. Will 1 gallon of paint be enough? Just read it. Should we go ahead and solve it?
No.
Yeah. Read it through again.
No.
12 times 15?
My goodness. Read it again.
Is it like 12 times
Read
15?
all those words, right? First, some students look at all those words and go, there's a lot of words on that page.
Yeah.
Is it like 12
I
times
hate story
15?
problems. There's too many words. Ah!
Yeah.
Do we need to do 12 times 15 here?
All right, so we got past there's all these words. We read it once. Now let's read it again.
And
But
help.
now we're going to start exploring it as we read.
Yeah.
Julia wants to paint 2 rectangular walls of her bedroom. Talk back to the text right now. Just that one line. What are you getting from Julia wants to paint 2 rectangular walls of her bedroom?
There are 2 walls.
With the rectangles.
Walls. Maria's saying they're rectangles. Do you feel comfortable with rectangles? Do you have experience with rectangles?
Yep.
Yep, already.
We talk back to the text and we go, all right, I'm starting to get an idea of what's going on here. I got 2 rectangles that I'm dealing with.
Mhm.
All right. 1 bedroom wall is 15 feet long and 8 feet wide. Talk back to the text.
So when
15 feet long
the
and 8
wall's
feet.
15 feet and 8.
So you visualize
15
a
by 8 feet.
rectangle? 15 by 8. Are you familiar with looking at something like that? Feeling something like that? Experiencing something like that? We've got a rectangle, 15 by 8. All right, continue on. The other wall is 12 feet long and 8 feet high. Stop. Talk to the text.
12 by 8.
12 by 8. Yep.
Yep, we got another rectangle, 12
So
by 8.
15 by 8
so
and 12
far,
feet by 8.
I'm talking back to the text. So far, I got 2 rectangles. I got 1 rectangle that's 15 by 8. I got another rectangle, 12 by 8.
Mm-hmm.
Bring it, problem. I've got this. I think I got this figured out so far.
Just beat it.
Right?
Beat it.
Yeah.
Yep.
All right, keep going. She wants to put 2 coats of paint on the walls. Huh. Talk back to the text. What do you want to say to it? Have you
She
ever
wants to
painted before?
Okay.
Have you have? Have you?
Some.
Do you know somebody that's painted before?
My grandpa and grandma, they're artists.
Heard of painting walls before?
Yes.
Yeah.
Yeah.
Yep.
Any
That
of
was
the
my
answers
house.
or no? Should you ask?
Yes.
Maybe.
Yeah.
You'd be like, "What's this painting all about? I don't understand." Are they painting a picture? Are they painting? I don't get it. What are they painting? And then a classmate or a teacher or a family member might say, "Oh, well, painting a wall means that you're going to get a brush or a roller and you're going to dip it in a bucket of paint. And you're going to put it all over the wall and you're going to make the whole entire wall the same color." Okay, if you've experienced something in a story problem that you have no clue what it's about. This one, it sounds like most of you are like, I kind of get it. I've heard of this being done. But you know what? I have a story. I'm teaching at college. There's a famous story problem in one of my college books about a farm grain silo.
Huh. Strange.
And it said, figure out the volume of the grain silo with a diameter of 20 feet and a height of 30 feet.
Mm.
And I had a bunch of students in my college class that have lived in the city all their lives.
Mm.
They were like, what the heck is a grain silo?
Mm.
And I said, oh, we got to explore that. And we pulled up pictures and we looked at them and we found out that they are these cylinders with spheres with half a sphere domes on the top.
Hence the diameter.
Right.
It's round.
So we had to figure out the volume of the cylinder and the volume of half the sphere and then add them together. But the students that lived in the city were like, what the heck is a silo?
Yeah.
And they're also explosive.
Right? They just didn't read those words and go, well, I don't know, I'll just punch some numbers in the calculator and write down an answer with an E after it. Right? They said, I'm going to ask. So, you ask. All right.
Yeah, the grains.
That 1 gallon of paint will cover 350 square feet. Stop. Talk to the text.
So she knows that 1 gallon of paint will cover about 350 square feet.
What does that mean? A gallon of paint will cover 350. What does that mean?
It means we have to think about how much paint she'll need to do both walls.
Did you hear what Erica said? We'll have to think about how much paint she's going to need to do both walls.
And
Yep.
2 coats on them.
How many coats? Miss Peggy, can you help out the group? What does that mean by coat? We're going to put a coat on and zip it up and go outside?
No, we're going to put roller or brush the paint onto the wall.
Yeah,
Yeah.
that's a coat of paint. So isn't this funny how like words, especially in English, mean different things? Because if I was to say
Yeah.
put on a coat, you'd all put your coat on and we'd all go outside, right? Or jump up and down in here and get really
Yeah.
hot and sweaty. But
Yeah.
a coat of paint, oops, not the same thing. And maybe you don't quite understand what that means. Now, Erica did. She goes, oh, we've got to figure out how much these walls are going to take. So in your problem-solving group or whatever, you're talking to each other, she's cluing you in on that. Peggy cluing you in on to, oh, it means how much paint is going to cover the surface of the wall. We're going to splash, we're going to put it on with a roller or a brush. And if we have a gallon sitting in front of us. So do you know what a gallon of paint looks or feels like? Yeah?
No.
You never seen one. So you might want to ask about that. Like, what do they mean by that? And somebody would say,
I mean,
oh.
a gallon is like when I think of a gallon, I think of like a gallon of milk.
Yes. So you draw from your experience and you say, well, I don't think I've ever thought of a gallon of paint, but I do know what a gallon of milk feels like. So you're right. A gallon of milk is very close to the same size as a gallon of paint. But we're not going to paint our walls with milk.
True. It's
right?
just the same size.
So, but it is around the same size. So you're talking back to the text. You're experiencing it. You're relating to it. You're going, okay, so I got this gallon of paint, and if I brush it or roll it on, it's going to cover 350 square feet. But I pick up on one coat. What did you say earlier?
2 coats.
2 coats. Which means the walls, and then I paint them again.
But if we paint,
when we go outside, right?
Yeah.
But if we paint our walls with milk, can we put cookies on it afterwards?
Yeah. Then that's a whole nother problem. How many cookies will we need? You have to figure out the area of a circle. You're a cookie, or maybe it's a square cookie like a taffy or something. I don't know. Anyway,
That was
so
clever. That was clever.
I like that. Or a brownie. We got all sorts of things we could do.
Chocolate.
Back to our paint, though, right? We're painting with paint. The trick on this problem that you had to pick up on is you're going to paint it twice, right?
Right.
Okay. So we're talking back to the text, and it'll say, will 1 gallon of paint be enough? That's the question.
Yeah.
Now, we explored it.
Yep,
What is our plan? What are we going to have to do to figure this out?
Figure out the square feet of both walls.
Yes. So there's one part of our plan. So we either keep this plan in our head or we write it down. It doesn't matter. I'm going to write it down for us just, to keep us straight. So the first step, I'm hearing step 1. Figure out square footage of the walls. Okay? Once we figure out the square footage of the walls, what do we want to do?
Find the area.
That is the area. That's the same thing, Zach. So you're right on the money, right there. Find the area of the walls.
Square footage, yeah.
Okay, so we found the area of the walls. Now what?
Then you need to double it.
Peggy's offering up that we need to double it.
Yep.
That's true, yeah.
Why do we need to double it?
Because it's 2 coats of paint.
2 coats of paint, Zach. It's not that it's 2 walls, Justin.
Right, you're
We
right.
got 2
You're right.
walls. We
You're right.
figure out if we just paint these 2 walls once, but it told us to paint it twice, 2 coats. So we got to double our square footage, don't we? All right, so we're going to double the area. Then what?
Yeah.
We get that number, then what?
It asks if 1 gallon will be enough.
And it asks us if 1 gallon will be enough, and 1 gallon covers 350 square feet. So how are we going to answer that question? What, Erica? What? It'll be there? Or
That'll be enough.
You're thinking it'll be enough. She's already doing it in her head over here. But we need to compare numbers, don't we? We need to look at what we're going to get, and then look at how much of a gallon of paint will cover, and answer the question, yes or no, right? Okay, so there's our plan. All right, so Erica's over here already doing the plan because she likes mental math. So Erica, what did you do first? Our plan was to figure out the area, so what did you do first?
The length times the height.
The length times the width or height, so 15 times 8 on the first wall.
Yeah, and that's 120.
120. Yep. All right. And then
I did the same thing for the second wall.
Okay. 12 by 8.
96.
96. Then what?
Then I doubled
the numbers and added them.
Okay, you doubled the numbers and added them. So 120 doubled is 240.
Mm-hmm.
96 doubled is 108, 192.
Oh, yeah.
Yeah? 240 and 192.
No, it's not enough.
It's not enough.
132, yeah.
What is it?
432.
432
Feet squared.
feet squared. 1 gallon of paint at 350 square feet, enough? No.
I guess not.
So when we go to the store, we should probably buy
A couple gallons.
2 gallons of paint.
Why not hands squared?
What?
What? Because we were told it was in feet. If they measured it in hands, we would say hands
I
squared.
get it.
We're not measuring.
Horses, that's right.
That was clever,
Okay.
Zach.
JJ,
All right. Yes, Maria.
I noticed that we could have put that into some sort of an equation and proved it true or false.
Okay. Talk us through it.
Like, we could have put it into, okay, where's the problem? Like, you were saying, okay, we have to do this operation and then that operation,
Mm-hmm.
and we could have arranged it into some sort of a problem
Right.
predetermined and then plugged our numbers in.
Yes. So, I think I hear what you're saying is if we take area equals length times width, but really what we need is area and length times width, we need 2 of those, right? So we would need area equals length times width plus area equals length times width, right? We'd need the 2 areas, and we'd have to double them. So we actually have 2 times the areas, right? And that has to be greater than 350. Is that the equation you were sort of thinking about?
Yeah, I knew it was possible
Yeah.
somehow. I wasn't sure
They
exactly.
gave us 350 as the area. It's an inequality, isn't it? We're not going to have it be equal to. Well, it
Yeah.
could. It could be greater than or equal to. So our 2 areas, we could say area 1 and area 2, right? We could say area 1 and area 2 are added together and then doubled, right? And that number has to be greater than or equal to 350. Yes. That is a more advanced equation way of solving the problem. And my math heart is pitter-pattering, Maria, because that's stuff that you learned last year. It's an inequality equation, isn't it?
Nice.
And I noticed that when Zach tries to speak up, I can hear him, but it seems like you can't. Like he was calling your name earlier.
Yes.
I wasn't.
Okay, if people are talking, if you're talking and then someone else tries to talk, I do have to listen carefully. Yeah. So it's okay to yell at me.
Yeah.
I give you permission. I'm giving you all sorts of cool permissions as a teenager. You can, yes, Erica. Hi. Yes, Tabitha. I don't.
Crap.
Oh. Oh, crap. In my class, it's okay to yell at me and it's okay to talk back.
As long as you don't talk back mean.
Yeah, you're respectful. But
Yeah.
sometimes we say, oh, crap. All
Well,
right.
well, crap isn't a bad word
It
necessarily.
isn't. It just means that it's crap. It's junk.
Well, garbage.
Okay, garbage. All right.
Crap a lot.
All right. Nicely done on getting your way through that problem using all your techniques. All right.
Nice.
Let's go try it again. I want to make our way to a crazy problem. Oh my goodness. Let's see.
A crazy
I
problem,
know.
huh?
Let's make our way. This is a good one. Let's make our way all the way to page 40, number 31.
Oh, fancy now.
So page
Is it just-
40.
just
I'm
40
going to
straight up?
guess that it's probably 40A or B. You'll have to let each other know.
Oh, I went way too far.
39,
I went-
going on 40.
You 40.
I found the 40.
No,
30,
it's just a word.
30 what you
I
said?
got it. Wait.
31.
Okay, well.
31, page B40.
Is it B40?
It's B40.
Okay, found
Like almost to the middle of the page.
All right.
found it.
Thank you for the
Did I beat you, Tabby?
orientation and mobility to our Braille.
30, here it is.
Who say do this?
Page 40, number 31 on B40.
Oh,
of
whoops, I went
Braille.
to 30. There we go.
And we have, it's titled remodeling. So we're gonna remind ourselves that we are mathematicians.
Yeah.
We're not.
It's close. It's
We're not.
close to that half a page, but it's kind of at the end of a quarter.
We're mathematicians. We are going to put on our mathematician brains, our aspiring geometry attorney brains. We're going to take a look at this problem as mathematicians. Who would like to read it? Tabitha.
Tabitha chose.
Remodeling. A remodeler charges $3.25 per square foot to refinish a wood floor. Oh yeah, floor. How much would it cost to finish a wood floor that measures 30 feet by 18 feet?
All right. We read it once. Should we read it one more time?
Sure.
All right. Let's read it again. Someone else.
I could.
Okay.
It says remodeling. A remodeler charges $3.25 per square foot to refinish a wood floor. How much would it cost to refinish a wood floor that measures 30 feet by 18 feet?
All right.
You sounded like a computer
Yeah,
at the last.
Talk back to this problem. A remodeler charges $3.25 per square foot to refinish a wood floor. Do you know what that means?
He's gonna give you.
He's
He's gonna make you pay $3.25 for every square foot.
He's gonna make you pay $3.25 for every square foot. So if he comes in and he just refinishes one little square, 1 foot by 1 foot, he's gonna say, "Please give me $3.25," and
He's
he's gonna
cheap.
leave.
Can I have him?
No,
that's not cheap. No?
That's not cheap.
It's not cheap.
He's not gonna come to your house and do 1 square foot.
We're doing some remodeling right now. The corner of her house.
Be 3 inches by 3 inches.
What's that, Maria?
Wouldn't 1 square foot only be 3 inches by 3 inches?
No, 1 square foot is 12 inches by 12 inches.
But
Think about it.
remodeling is expensive.
You're thinking
1 square
perimeter
foot,
again.
it's a 12 inch by 12 inch. A foot by a foot is 12 by 12. 144 square inches.
But remodeling is expensive.
All right, so you got a remodeler coming in. He's going to refinish your floor. Have you heard of that before when people refinish floors?
They're like changing the flooring.
Yeah.
They're changing the flooring. This is probably a refinish, means that the floor is wood,
Mm-hmm.
and they're going to strip off the old varnish, and they're going to put on a nice, fancy, new coat of varnish. Anybody been in a gymnasium before?
Yeah.
So usually the gym floor is a wood floor.
They're really smooth.
That they're really smooth, and there is a finish over the top of them to make them really smooth. Wood floors are in our houses sometimes, and there's a finish over the top of them.
Tile too.
All right, there's tile sometimes, and that
Like
can
we
be a
finished,
project.
like stuff in the wood shop,
All
we
right,
just finished
yeah,
it.
this is a wood floor, so he's just going to refinish it, or she is. I shouldn't say he. She might.
Yeah.
All right.
Some of the
Okay. How much would it cost to refinish a wood floor that measures 30 feet by 18 feet? Talk back to the text.
No, how much would it cost?
What are they talking about as far as the shape is concerned?
It's a rectangle?
A rectangle.
And it's 30 by 18.
It's 30 by 18. So what's your plan?
To multiply 30 times
Which you're doing multiplying 30 by 18. What are you finding?
the area, which is 540
540.
Yeah.
What?
Square feet.
Square feet.
square feet.
Divide by 325.
You're going to divide by 325. That's someone's plan. Does anyone else have a different plan?
Wait, why would you divide?
That
I don't
is-
get it.
Oh, Naramar, speak to the group. Why would you divide?
Why would you divide? I don't get it.
Because you have to figure out how much money you owe them, so you divide that number by cost.
Oh, okay.
If I'm
Right, that makes sense.
does anybody else want to say what we're supposed? So Tabitha's saying we divide the number. Anyone
What do
disagree?
you think, Maria?
I would agree with Tabitha because, I mean,
That
dividing
makes sense. You
square
divide by how much
feet
it
by the
costs.
number it would cost.
You would,
Divide.
I think you multiply.
Oh,
Your house, and I'm going to refinish 540 square feet. I want $1 for the first foot, $1 for the second foot, $1 for the third, $1 for the foot, or not, excuse me, 325.
that's like
325, 325, 325, 325,
that's like
325, until I do 540 of them.
that's like 166 and 15 cents.
No.
Dang it.
Erica, speak up. 540 square feet, and I'm going to charge
Hmm.
$3.25 a foot.
Oh, here we go.
Do you want the brailler? Or the graphing calculator?
some sort of calculator.
Multiply. Erica, explain why you would multiply.
I'm looking for it.
Well,
$1,755.
you wouldn't be getting the full price if you divided 540 by 325.
Yeah, you'd be giving them free refinishing, wouldn't you?
Mm-hmm.
It's $1,755.
Whoa!
$1,755.
I'm not gonna. No.
Yeah,
Why
you have to multiply. If you go to the store and buy 540 Hershey bars,
Jeez.
are you going to divide 540 Hershey bars by the cost of the Hershey bar?
Probably not.
The
No.
store is going to arrest you for shoplifting if you walk out of the store with that. Right?
But
You're going to multiply your
Wait.
product, right? You have a product that you're multiplying by the cost.
Why would you want to lift the shop? It'd be too heavy.
All right?
the most the biggest price I've seen for a Hershey bar is a 10-pound Hershey bar for $100.
Wow.
Jeez.
All right. I want to do something
I
here.
would.
I want to do now. Tabitha's cruising along. She's at home. She doesn't. Oh shoot! I want to get to my.
Oh, be quiet,
I
calculator.
don't. Oh shoot, JJ. I do not.
Main menu.
I want to get to my main menu. Where's my main menu?
I don't know. I'm not sure how to use that device. I don't remember how it works. I don't like that voice, I'll be really honest.
What
does he say about that?
That's a stupid
Okay, so we're gonna take. So Tabitha at first at 540 divided by $3.25. So it gives you 166.15.
Yeah.
So if
Yeah.
you got that number by yourself, Tabitha, and you examined it, you said, hey, I got a remodeler coming to my house. He's going to refinish my entire floor for $166. 540 square feet at $3.25 a square foot. Does $166 make sense?
Nope.
No. So you go, oops. I think I did something that doesn't make sense. Let me go back and reread my Oh, I need to multiply. And then you would have multiplied, right?
Yeah.
Sometimes in our plan, we do, and then when we go to examine it, we go, uh-oh.
That's not right. We
That
gotta fix
doesn't
that.
that doesn't make sense. It doesn't make sense that I would have all these square feet that he's doing, and he's going to do 540 of them, and each time he does one, I owe him $3.25, and he does 540 of them, and I'm only going to give him $166. Oops. Right?
Yeah.
That's the examine process.
Yep.
Make sure
Definitely.
the answer makes sense, and then that catches you, right?
Yeah.
You catch the error, you analyze it,
Yeah.
and then you do it again.
Yeah.
Mistakes are good in my class, by the way. Oh my gosh, you just got told you get to yell at me, talk back to me, and make mistakes. Or as Tabitha says, mess up.
Mistakes aren't just good in here, they're good
Please.
anywhere.
Please mess up in my class.
If you say sorry, that means you made a mistake and you
What's
won't do
4
it again.
Why are mistakes important?
4 plus 4 is 10. No, I'm kidding.
Help me
It
out.
helps
Why
us
are
learn.
mistakes important?
You learn from them.
You learn from them. Did you
Yeah.
come out of your mom a little blob and just start running and talking and solving quadratic equations?
Nope. You guys learn.
You did?
Came out a premature blob.
Miss Humphrey said she did, so we'll just have to take her
She's
for a
not
word.
human, JJ. Don't listen to her.
I was born
Going
6 weeks
backwards,
early.
like Benjamin Buttons. She's going backwards.
Oh
I
man.
was,
We
I was
we
born
come
6
out
weeks
of our
early.
mom and we make mistake after mistake after mistake and we learn from them, right?
Yeah.
We're laying on our little baby mat and we're
everywhere.
trying we're trying to roll over because we're not comfortable. So we flail our body one way and it doesn't work. And we flail our body the other way and it
fall off the
doesn't work.
crib.
And we kick our feet and we fall off something. And then all of a sudden, through our mistakes, we realize, oh, this is how I do it, and our body does it, right?
Yeah.
When we try words out, we want something, ooh, that candy tastes good, and we say, and all of a sudden it's like, candy, right? Right?
Don't we
Just look at it and say, candy.
Yeah.
Yeah.
Yeah, I did.
I know. Is that what you did, Humphreys?
Yeah. Again, she's not human.
She's a savant, right? Okay.
So
Candy is bad for your colon.
Most of us, 99.9% of the population, we make mistakes from the second we're born
yeah.
until you are right here in front of me going, yep, I'm going to make a mistake. And Smith
JJ.
made a mistake.
And
It
then-
don't matter. I'm like, yay!
And then you're
She made a
gonna
mistake.
and then you're gonna catch
we
it.
all learn from it. Yeah. We all
Hey,
learn from
JJ.
it. Do you think Tabitha will make that mistake again?
Probably.
Maybe.
Do you think she'll figure out what she did wrong?
No.
Yeah.
Maybe.
I think she will. And then she'll
Maybe.
go, all right.
You have to analyze it and then try to correct it.
Yep, you analyze it and correct it and learn from it. So you
Hey,
have permission
JJ.
to yell at me, talk back to me, and
JJ!
make mistakes.
She's trying to at me.
All right, throwing markers at each other too.
Hey, JJ.
Calculator, shut up.
Candy is bad for your colon.
Mental.
She threw a marker.
Okay, let's
Oh,
back up. I want
right,
to back up to a
Abby.
really crazy problem, and I think it has a crazy tactile.
Ah.
So back up to page 39.
Thanks, JJ.
39
I'm going to
what?
guess that it's A or B, number 11.
Number 11? Okay. Oh, calculator, be quiet.
30 seconds to empty B.
C. No, it's B. That's B.
B?
B, B39,
Blah.
and it's number 11.
It's page tab B 39.
Interior design.
Yes, Tyler.
I'll be here all week this time.
What?
It's
Okay.
10:57, 58. Okay, and there's a tactile to go with it. The tactile's not horrible. It could be a heck of a lot bigger, but we'll make our way through it. This relates to kind of the first example that we had in this book, in this chapter, this section, when we looked at the walls of the bedroom and figured out the perimeter.
Mhm.
Okay? All right, it says interior design. Who wants to read? Maria?
Okay, if I could find the thing. Example 4.
Yeah, yes,
Yes.
it says example 4, number 11.
Interior.
Interior design. That one.
Mm-hmm.
An interior designer wants to order wallpaper border to place at the top of the walls in the room shown below. One wall of
If one roll,
if one roll of border is 9
5.
or is 5 yards long, how many rolls of border should the designer order?
Right, so we read it once. There was some weird words we had to get through on it.
Read it again.
We should read it again, shouldn't we? It's okay to read it again. This isn't a speed contest. An interior designer wants to order wallpaper border to place at the top of the walls in the room shown, you say at the bottom, right? Below?
Yep.
Talk back to the text. Do you know anything about wallpaper or wallpaper borders?
I
What I'm assuming keeps the wallpaper on.
Okay. We're gonna put wallpaper. So wallpaper is paper we put on the walls.
The wallpaper border is just like to the edges.
Hey, so Erica has some experience and she's sharing that with you. She said wallpaper border is something that you just put along the edges of the walls.
And it's usually the top edge of the wall, and it's usually about 6 inches wide.
So another member of your problem-solving team gives us more information. She's like, hey, it's usually at the top of the wall. It's usually about 6 inches wide. You're talking back to the text. You're talking to each other. You're asking questions of whoever you're studying with, or maybe you don't know and you're Googling it. What the heck is wallpaper border? Right? And Google, or you ask Siri, Siri, what's wallpaper border? And Siri will tell, oh, here's what I found on the web.
Border.
And a wallpaper border.
No comment.
And then
I
you'll
don't
see those
understand what you mean
border
by.
advertisements will be wallpaper border for a while, but you know, it works. You have
Hey, JJ.
resources. You have each other. You have Google. You have your phones. If you're not sure what the heck they're talking about, you better figure it out first before you move on. So now that we know that border from our friends and our problem-solving group, the border is this wallpaper that we stick to the wall that goes around usually the top edge of the wall. It's not the whole wall. It's just going around the top edge of the wall in our room. Okay, cool. All right. And it's really exciting, according to Naramar. All right.
I don't understand what you mean by.
One roll of border is 5 yards long. How
Cool.
many rolls of border should the designer order? Talk back to the text.
A bunch?
Yes. So Erica's saying, I want the graphic explained to me. I guess we all should go look at the graphic now because they just put one on the paper, right? So they have a room. I'm going to start at the top left corner, and we're looking down on this room if we were to hover over it. And there's a wall that's 8 feet long, and then it goes straight down for 4 feet, and then it goes over a teensy bit to the right for 1 foot, and then it goes straight back up for 4 feet,
Wait,
and then it goes
on the top left or the top
over
right?
to the right for 8 feet. So just in the top part of our drawing, we start in the top left, we go right 8 feet, then we stop and go down 4 feet, then we go to the right 1 foot, then we stop and go up 4 feet, and then we go back to the right 8 more feet, and now we're at the top right hand corner. Then we go all the way down to the bottom right hand corner, and that is a 16-foot wall. Then we go to the left 6 feet, and then we go up 4 feet. We go over to the left again 11 feet, and then we go all the way back up to the left and connect where we ended up with a 12-foot wall. Lots and lots of little measurements going around this room. It's a weird room. It's got little bump outs and indents and who knows what it's doing, but it's this funky little room that we're looking at. Now, they gave us all these measurements. You advocate for yourself like Erica did and said, can you draw this for me and explain this drawing to me?
Yeah.
You might not be able to make out all the measurements, and you want somebody to, one of your, peer study buddies or a parapro or a proctor to say, can you please read me off the measurements again? So we're going all the way around this room. What's our plan? What do you want to do?
We've already evaluated the room.
We've evaluated the room. Tabitha's offering up that we need to find the area. Anyone else with a different plan?
Suggestion. That's a good suggestion.
The area. All right, anybody else with another suggestion? Is a border covering area?
Oh.
No.
Perimeter. You patrol the border, right? Perimeter.
Yeah.
So we're actually going to find the perimeter, aren't we, of our room? That's our plan. That's one part of our plan, is to find the perimeter.
Mm-hmm.
Did you notice how they measured the room? What's its unit?
It's feet.
Feet.
Just plain feet, not square feet.
How much is a yard? How much is the rolls explained in?
I said 5 yards.
5
5 yards.
That's 15 feet, Erica said. She talked back to the text. I asked her to talk back. I said, the border said 5 yards. Erica said, ha, that's 15 feet. We need to make sure we're in the same units, right? So we note that to ourselves, or we put that in our plan, that actually one roll is 15 feet. Okay, so we're going to find the perimeter of our room. So we're going to add 8 and 4 and 1 and 4 and 8 and 16 and 6 and 4 and 11 and 12. Tick, 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 tick. I get 74. Is that what you got?
I got 80.
Sure. What'd you get, Peggy?
80?
80. Let me try again. 8 and 4 is 12, and 1 is 13, and 4 is 17, and 8 is 25, and 16 is 41, and 6 is 47, and 4 is 51, and 11 is 62, and 12 is 74.
Okay.
Wow.
No, that seems
How
about
did I
right.
do that? 12,
74.
8, 4,
The mathematical
1,
error, Peggy.
4, 8, 16, 6,
Always try again.
4, and 11.
And then 12.
Must have made a mathematical
Yep.
error.
Yeah, I've had 12 at the top.
Okay, 12 on the side there. Okay.
So 12 and 8 is.
All right. So we have 74 feet. We know a roll covers how many feet? What are we going to do? What's our plan now with the 74 and the 15? Add them together?
Mm-mm.
That's okay. You caught yourself. 74, and a roll of border covers 15 feet. And it's asking us how many rolls do we need? 1,110 rolls.
Wow.
Does that sound right? Nope. Okay.
I was like,
You did it backwards. What do you want to do, Smith?
I'll divide.
Divide. See, we examined the problem when oops
74 by what?
by 15.
Yeah, there we go.
4.9. Okay, that makes more sense.
4.93 rolls. How are you going to answer this question? Can we buy 4.93 rolls in order? 5 rolls. The answer to the question is 5 rolls.
You would round that, wouldn't you?
You would round it? Yes. Even if it said 4.2 rolls, how many would you buy?
5.
5 rolls.
5.
If you're doing remodeling, you don't want that 0.2 of your wall not covered in something.
No.
Well, sorry, I rounded down.
Better luck next time.
Yeah. Sorry, I rounded down because it was 4.2, and I was always taught round down. Right.
It's 11:06.
It is 11:06.
We should probably head out for lunch.
11:08. Yep. All right.
Probably head out.
Nicely done, everyone.
Thank you.
Problem
Good.
solving, talking back, making
Not 11:15 yet.
coming up with a plan, examining your answer. Oops, 1,000 rolls of border. That
Doesn't
sounds
sound
a little
right.
off. I did it backwards. Smith was our star student today.
Really?
Why was she our star student
She
today?
corrected her mistakes.
Because she
perfectly.
made mistakes and we all learned from them. And we had
Should
fun
we
doing it.
give Tabby a gold star?
We are giving Tabitha another paw for taking the risk of making the mistakes for us so that we can learn. What number?
I don't know what we have here.
Oh my God.
All right, nicely done.
Miss
That
I
was
think
called,
we have
that's
Spartans.
called being safe, right? We're supposed to be safe, be kind, and be respectful. Well, Tabitha made the mistakes for us to keep us all safe,
Miss
right? All right.
I don't know what type of things we have here though.
Class. I'm going to stop recording and then say goodbye.